Hi there. So the next problem that we're going to focus on is this problem right over here. And we're going to focus on estimating. And so we're going to estimate by rounding, and we're going to use easy numbers to estimate. So I can see here 51 can be rounded down to 50. So I'm going to write it down here, but I would make a mental note. So round 51 down to 50. Okay, so we're going to go ahead and ask ourselves again, like we do with every division problem, how many times does 51 fit into 6? Or how many times can it go into 6? And that would be 0 because 6 is too small. So we're going to write our 0, our placeholder 0, right on top of the 6. And now we're going to go ahead and look at the next unit, which is 63. And when I estimate, I know 50 times 2 is 100, so that'll be too big for 63. So I'm going to go ahead and put a 1 in the quotient bar there, and then I'm going to multiply. So 51 times 1 is 51. Then I'll go ahead and do the standard subtraction algorithm. So 3 minus 1 is 2, and 6 minus 5 is 1. Now we're going to start our second step, and this is our new number to divide. So we bring down that 2, and our new number is 122. And so we're going to ask ourselves, how many times did 51 go into 122? Well, if I use easy numbers to round, I know 51 rounded down to 50 is rounded down is 50. And I look at the number 122, and an easy number that would fit with 50 would be 100. So I'm going to round 122 down to 100. And so now that would be a nice guess and test way to figure this out. So 50 times 100 is 2. So I'll go ahead and try a 2. So I'm going to go ahead and put a 2 over the 2. Remember to keep them lined up. And so now we're going to go ahead and multiply. So I'm going to take this on our scratch paper on the side. And so we are going to multiply 51 times 2. Which is 102. And I'm going to write that right over here. And we subtract. So we do the standard subtraction algorithm, and 2 minus 2 is 0, and 2 minus 0 is 2. Now, this is our next subtraction step. Remember, it's repeated subtraction is repeated subtraction. And we bring down the 9. And now we're going to divide 51 into 209. And so I'm looking at the 51, I can round that down to 50. And I can round 209 down to 200. So let's make a mental note, but I'm going to write it up here. So we're going to round 209 down to 200. Okay, so how many times can 50 fit into 200? That would be a 4, because 4 times 50 is 200. So I'm going to go ahead and try a 4. And so let's go ahead and go over to our scratch paper here. So 51 times 4, that would be 4 times 1 is 4, 4 times 5 is 20. So my answer here would be 204. So I'm going to go ahead and write 204 right there. And I'll go ahead and do my traditional subtraction algorithm. And 9 minus 4 is 5. And there's nothing else to bring down. So I have a remainder of 5. And turning that into a mixed number, I'll go ahead and make 5 into a numerator, and 51 would be the denominator. Therefore, my answer is 124 and 5 51sts. Okay, so the last long division algorithm that we're going to work on is going to focus on this rule. If the remainder is equal to or greater than the divisor, you underestimate it. So I'll be doing a guess and test, and you'll kind of see what happens. So first of all, I'm going to do the same thing. I have my 2-digit divisor here, and I see that 27 can probably be rounded to 30. So I'm going to go ahead and write that in here. Round 27 up to 30. And I'm going to ask myself again, can 27 fit into 9? No. So I'm going to place my placeholder 0 up there. Now I'm going to look at the next unit. And an easy number that I could round 97 to would be 90. So I am going to round 97 down to 90. And so 30 goes into 90 3 times. So I think it's, I'm going to go ahead and try that number. So I'm going to go ahead and put a 3 on top of the quotient bar up there. And so let's go ahead and multiply. So 27 times 3. This is on my separate scratch paper. So 3 times 7 is 21. And 3 times 2 is 6, 7, 8. And let me go ahead and write that in there. And so the answer is 81. So I'll go ahead and write 81 in there, and I'll subtract. So 7 minus 1 is 6, and 9 minus 8 is 1. And so 16 is smaller than 27, so we're good to go. And now I'm going to bring down that 2. And that will create our new number to divide. This is the next step. Remember, long division algorithms are a series of steps. So bring down the 2. And so now I need to think about 27 going into 162. So I'm looking at 162, and I'm thinking I can probably round 162 down. So I'm going to round 162 down to 150. Because I'm looking at a 30, because I'm going to round 27 up to 30 and 162 down to 150. So those are nice friendly numbers with that, with the 30s. And so I know that 30 can go into 150 3 times, 4 times. It can go in 5 times. So I'm going to go ahead and do my scratch paper work over here. So I'm going to go ahead and try a 5. Okay, because I know that 30 times 5 is 150. So I'll go ahead and do my scratch paper over here. And so 27 times 5. So let's do the algorithm here. It's 5 times 7 is 35. And 10 times 2 is, 5 times 2 is 10, and that's 13. So that would equal 135. And let's see, let's go ahead and subtract here. Let's do our subtraction algorithm. And so that's 7, and 5 minus 3 is 2. Now 27 is the same as 27. Oh, that's bad. Okay, so that's not going to work. This is an example of the remainder being the same as the divisor. So I can actually go on up. This should be a 5 up here. So I'm going to go ahead and make that a 6 now. Okay, so let's go ahead and take my tissue here, and I'm going to redo this part here. Okay. And so 7 minus 1 is 6, 9 minus 8 is 1, and I'm going to bring down the 2. And this time I'm going to try a 6 because the 5 was not big enough. I had underestimated because the remainder was the same as the divisor, okay? So let's go ahead and multiply 6 times 27. So 27 times 6. And so that would be 42, 12, 13, 14, 15, 16, 162. Okay. And I will go ahead and not finish there. I have 0 here, so now I need to bring down this 4, okay? So I'm not finished yet. This is our next step. And so this is a 4. And so, again, I'm going to ask myself, how many times does 27 fit into 4? And 0 times. It's actually too big to fit into that. So I'm going to write my 0 up here. And so 0 times 27 is 0. And I will go ahead and do my normal subtraction algorithm. And so 4 times 0 is 4. Now I don't have any of the numbers to bring down, and I can go ahead and turn that into my mixed number. This is my remainder. So my remainder would be 4, and my denominator would become 27 over here. So my final answer would be 360 and 4/27. Oh, and let me go ahead and talk about some of the rules to remember throughout these 2 videos. I kept messing up on them. So, so the first rule to remember are division algorithms are repeated subtraction. Okay, so when you think of it that way, it's just repeating the subtraction problem. And so it's not as intimidating that way. The second rule to remember, keep the digits lined up correctly. And that's where you can use that placeholder 0 to help you keep those lined up correctly. And the next rule to remember, you can estimate by rounding the divisor and unit you are working on, and make sure you estimate using the easy numbers, okay? And the last one, if the remainder is equal to or greater than the divisor, you underestimated. So you'll need to take your eraser on your pencil and erase it and try a bigger number on top of the quotient bar. And then you'll be able to get your remainder. So that is the end of the video. And I will be coming out with a long division algorithm with decimals. So that will be the next series. And thank